Okay, now I'm going to show you how to identify an acid, a base, a conjugate base, and a conjugate acid in a formula. So we have an acid-base reaction here, and it's written out as an equation. So the first step is we're going to identify the acid. So we should know that a basic acid will start with a hydrogen in front. Okay, so that hydrogen in front means that it has this proton, and it makes it a proton donor. So it is easy to identify the acid before the reaction because it'll usually have that hydrogen up front. So there's our acid. So if it's an acid-base reaction, then the one it's going to react with will be your base. And notice this is ammonia, so it has that NH, which was one of the keys to knowing a base as well. Okay, so there's your base. Now, we're going to look at the second half of the reaction. Now, the proton donor, this HCO3, gave away its proton and became just the CO3 with a 2 negative charge. So it no longer has those hydrogens on it, and so it has changed to CO3, and whatever your acid changes to is your conjugate base. It becomes a base because it gave away its proton. Now this one is lacking protons. It wants protons, so now it's a proton acceptor. It wants that hydrogen back, so now it's a proton acceptor. Now let's take a look at what's happening to the base. So this base was a proton acceptor. It wanted a proton. And what did it do? It took that extra hydrogen. Look, that hydrogen changed from 3 to 4. So the NH4 is now your conjugate acid because now it has this extra hydrogen. That extra hydrogen, that plus sign right there, it tells you it's got this extra hydrogen to give away, so it is now a proton donor. So your conjugates are always on the right side of the equation, and then your acids and bases are on the left. Let's look at the second one here. We've got our hydrogen here in front. That makes that the acid. This hydroxide, that's a key too to knowing that's a base. So let's look and see, where did the hydrogen go? Well, we have this H2SO4, and this SO4 is over here with one H short, right? It no longer has that 2 there. There's no more 2, so it's one H short. So this is the one that lost the proton, so it wants one. It's going to be a proton acceptor, which makes that the conjugate base. And then we've got this OH, and this is kind of confusing because water, it can be an acid or a base. You can rewrite it like this, and you see that OH there. Now you know that that's what the hydroxide changed to, and remember the base always changes to an acid afterwards, and so that's the conjugate acid. All right, over here we've got H2O, which again could be written as HOH. So that's going to start with an H. That's going to be our acid. This is going to be our base, it's our NH3. Then the NH3 changes here. Since that is now, this went from a base, it's going to change to an acid. So that's a conjugate acid. This went from an acid, it changes to a base. That's a conjugate base. All right, hopefully that was helpful.